The first part of this video is about the CAST diagram. The CAST diagram is a little diagram that you will get used to using this year, and it's a way to help you simplify certain trigonometry problems, and it really is going to be useful. There's a whole history behind why the CAST diagram was invented and how it is actually used. However, as a student, you typically just want to know how to apply it, how to get the best marks possible so that you can finally graduate and move on. So I'm not going to give you a whole history lesson about how it works. I'm just going to show you how to apply it so that you can use it without any problems. So the CAST diagram starts off in this quadrant over here, which we'll call quadrant 1. It then moves in a anti-clockwise direction all the way back to quadrant 1. We can think of this as the 0 degrees, then it goes up to 90 degrees, 180, 270, and back to 360. And so, as we did say, this is quadrant number 1. This we'll call quadrant number 2, quadrant 3, and quadrant 4. So in quadrant number 2, we can see that the angles go from 90 to 180. And so what we're going to do is we're going to call this the 180 minus x quadrant. This will make sense a little bit later. Quadrant 3 goes from 180 up to 270. So we'll call this the 180 plus x quadrant. And then we'll call the quadrant 4 the 360 minus x quadrant, where x is eventually going to be some number that is less than 90. Alright, and then the last thing we're going to mention about this diagram is where CAST actually comes from. So, the CAST diagram stands for cos, all, sin, and tan. And so if you start in quadrant number 4, you can literally spell out the word CAST. Like that. These letters will all become much more familiar as we go on, but for now, that is a simplification of what the CAST diagram looks like. In this slide, we're going to learn how to use the CAST diagram to simplify the maths in trigonometry. It's a very easy procedure, so try follow along and you'll see how easy it is. So first, I'm going to draw the CAST diagram. And so there we've got our CAST diagram as we saw on the previous slide. And so I'm going to show you a few examples of how reduction works, okay? So here's an example. If you ever have something such as the cos of 360 minus x, then what you do is the following. You ignore the cos part and you look at the 360 minus x. If we can locate it on the diagram, then we can simply write the answer as cos x. Then what we have to do is look and see if cos is positive or negative in that quadrant. So because we are in the quadrant where it says cos, it means that cos is positive in that quadrant. And so cos 360 minus x simply becomes cos x. This will make sense as we do a few more examples. Let's try the sin of 180 plus x. So the first thing to do is to locate the 180 plus x, and there we see it. So because we've located it somewhere on this diagram, we can at least say sin x for now. Then we need to see if sin is positive or negative in that quadrant. Because it's a tan quadrant, it means that sin is negative, and so this answer becomes minus sin x. Notice we do not put the negative inside by the x, it goes in the front. Let's try 2 more examples, and by then you should have it. So here we have tan 360 minus x. So the first thing is to ask ourselves, can we see that on the diagram? Yes, we can. Wonderful. So that's tan x. Then we simply need to see if tan is positive or negative there. We can see tan's negative there, and so we can simply put a negative. By now, I'm pretty much confident that you understand. So in the next slide, we're going to do some examples. Here we have 6 examples that we're going to go through. But first, we should always do these questions with the aid of our CAST diagram. So the first one says it's the sin of 180 minus x. So remember, we look at the 180 minus x and we see
if we can find that on the diagram, and there we can find it over there. So we know that the answer is definitely going to have sin x in it. Then we ask ourselves, is sin positive or negative there? Well, because it's in the quadrant where sin is, then it means that the answer will simply be positive. And so that answer is just sin x. Next is cos 360 minus x. So 360 minus x is on the diagram. So we know that we can definitely have cos x as our answer, but then we just need to make sure it's not positive, or we need to see if it's positive or negative. So because it's in the quadrant where cos is positive, this answer will just be cos x. The next one is tan 180 minus x. Is 180 minus x on the diagram? There it is. So we can comfortably say tan x. Then we need to see if the answer is positive or negative. So because it's in the quadrant where because it's in the quadrant where sin is positive, it means that tan is negative. So the answer for that one is minus tan x. Number 4 is the sin of 180 plus x. So 180 plus x is on the cast diagram. So we can say sin x. And then sin is not positive in that quadrant. Only tan is positive in that quadrant. And so the answer is negative sin x. Number 5 starts with saying that cos of 180 minus x. So 180 minus x is on the cast diagram, which is good. So that means the answer is cos x. And then just to double check if it's positive or negative, it will be, because sin is positive in that quadrant, cos is negative. And then the last question says tan of 180 plus x. So 180 plus x is on the diagram, so we can simply say tan x. And then tan is also positive in that quadrant, and so the answer remains tan. So in summary, if you can identify the angle as either 180 minus x, 180 plus x, or 360 minus x, that is a good thing. After that, you simply need to work out if your answer is positive or negative for that particular trigonometric function. This year, we're also going to have 4 trigonometric functions that include a 90 degree. And so these 4 you simply have to memorize off by heart. And please do memorize them, because they will pop up in every single trig exam that you write this year. So I'm going to list them for you as follows. The first one is the sin of 90 minus x. Now there's a whole mathematical reason as to why the next thing I'm going to say is true, but what you need to simply remember for this year is that the sin of 90 minus x is equal to cos x. That's just something you should memorize. Okay? The second one will be cos of 90 minus x. This one simply switches into sin x. Note that in the previous slide, in all those examples, if something started with sin, then it ended with sin. But when you get to these 90 degree ones, they switch from sin to cos, or from cos to sin. That is very important to remember, as I see many students sometimes forget about this. I'm now going to show you the third one. The next one is sin 90 plus x. And luckily, this one also just becomes cos x. So far it seems very easy. It's only the last one that has a slight little twist, which I'm going to show you now. And so number 4 is the cos of 90 plus x. This one also turns into sin, but it just becomes minus sin x. So this is the important one that you need to remember. The other ones just become the opposite. And so please remember that anything with a 90 just becomes the opposite of what it was. Whereas what we saw in the previous slide, if it was a 180 or a 360, then it doesn't become the opposite. Okay, so that's very important. So in the next slide, we're going to practice a few of these that have 90 degrees. So let's see if you can remember. So remember we said that as soon as we see the 90 minus or 90 plus, we can comfortably turn it into the opposite. So I'm just going to quickly go down and just switch all of them. And then there's one of them that is a negative. And if you remember correctly, it's this one over here. And so that one's answer is minus sin x. Towards the beginning of this video, we looked at how to reduce certain things, such as the sin of 180 minus x, the cos of 180 plus x, and conveniently each of those was located on the cast diagram, and so it was relatively easy. But many times you're going to get given something that does not look like anything on the cast diagram. However, I'm going to show you tricks and ways that you can use to modify those things into things that do look on that do appear on the cast diagram, and then you'll know what to do. So for example, the first one that we could do would be the following. Cos of 540 minus x. So straight away, 540 minus x is not on the cast diagram. Okay, so we didn't even know where on that cast diagram that would be, but something that's very important is we could, let's say for example, that cos 540 minus x is somewhere over here. Let's say it's there. If you had to add 360 degrees to that point, you would come back to the exact same point. Or you could minus 360 and you would still be back at the same point. So modifying these angles that don't look familiar with the use of adding 360 or minusing 360 is a very, very good way to turn something that doesn't look familiar into something that is familiar. And so we have the angle 540. Now, would we want to make that bigger or smaller? Well, we would want to make that smaller, right? Because we only have angles such as 180, 360. We don't have 540. So what we're going to do is we're going to minus 360 degrees. And so in the bracket, it would look like this. So there we've minus 360 degrees. And there's nothing wrong with that because mathematically, we will still be at the same position on the cast diagram. Now it's simply a case of simplifying that bracket, putting all the like terms together, and so what you end up with is 540 minus 360, which is 180, and so we end up with the cos of 180 minus x. And look at this. This is something that is on our cast diagram, and so we can comfortably say that that equals cos x, and then we should just see, is cos positive or negative in that quadrant? Well, it's negative because that's sin's quadrant. And so the answer to that whole problem becomes minus cos x. And so in the next slide, we're going to go through a couple of examples where I will show you all the different tricks we can use to modify these things so that they suit the cast diagram. And so here's 8 questions that are going to really show you all the little tricks that they like to throw in the exams. So let's start with number 1. The first one says sin of x minus 180. Now, guys, x minus 180 is not the same as 180 minus x. Because when you are minusing, the order in which you do it is completely... the order that you do it makes a huge difference. For example, 5 minus 3 is 2. But 3 minus 5 is minus 2. And so the order does matter when minusing. So sin of x minus 180 is not the same as 180 minus x. So remember, what we can do is we are always allowed to add or minus 360. So there's a bit of a skill when it comes to this. So you already have x minus 180. Now if you had to minus 360, you would go even more negative. So in this one, we are actually going to add 360. And so we're going to end up with x minus 180 plus 360. And if you had to simplify that and put all the like terms together, you're going to get x plus 180. Now I know that that doesn't look exactly the same as something on the cast diagram, but in fact it is, because when you are plussing, the order does not matter. I'll show that to you. 5 plus 3 is 8, and 3 plus 5 is also 8. And so the sin of x plus 180 is the same as the sin of 180 minus x, which is something on the diagram. And so we can turn that answer into sin of x And then because it's in the quadrant where sin is not positive, we'll just put a little minus in the front. And so that one is now complete. The next one says sin 540 minus x. So this one we will have to minus 360. And then if you had to simplify all the like terms, it's going to give you the sin of 180 minus x, which is over here. And so this just becomes sin x. And because it's in the quadrant where sin is positive, we can leave that answer as a positive. The next one is cos minus x. Now, cos minus x is not on the diagram. So what we can do is we could add 360 degrees to that. And then because we are plussing, the order doesn't matter. And so this can be rewritten as cos 360 minus x, which is on our diagram. And so we can write that as cos x, and the answer is positive because cos is positive in that quadrant. The next one says tan, oh no, sorry, I was looking at number 5. Number 4 says the sin of negative x. So we're going to follow the same procedure where we can add 360. When you plus, the order doesn't matter, and so that's the same as 360 minus x, which is on the diagram, and so that becomes sin x. But because sin is not positive there, because this is the cos quadrant, we can put a negative in the front. The next one is number 5, which is minus x minus 180. So we're going to add 360. And if I had to minus 360, you would go all the way down to minus 540, which wouldn't work so nicely. So we rather add 360. And so that's going to give us that over there. And then we can put these two like terms together, which is going to give you minus x plus 180, which isn't something on the diagram. However, there is a plus in between. And so when you plus, the order doesn't matter. And so that is the same as 180 minus x, which is on the diagram. And so we can simply take the answer as tan x, and then because tan is not positive there, we'll just add a little minus in the front. The next one is sin of 720 minus x. Definitely going to minus 360 because we need to reduce that 720. So 720 minus x minus 360. You can then simplify and put all the like terms together. That's going to give you 360 minus x. There we go. It's on the diagram. So we can write that as the sin of x, but sin is not positive there, so we put it as a negative. The next two are extremely important. Many schools don't really include these two, but I have seen some schools do it, and they can be quite tricky, but I'll show you a few tricks of what we can do. So the first thing we're going to do is take out a common factor. So this is number 7 that I'm busy doing, which currently says x minus 90. We are only used to 90 minus x or 90 plus x. Remember, we did the ones with 90 degrees, but we aren't used to x minus 90. So what we're going to do is we're going to take out a negative as a common factor, and that's going to leave you with minus x plus 90. So I'm just going to rewrite that part, because remember, when you're plussing, the order doesn't matter. So I'm going to write that as 90 minus x. Now here's where it gets a little bit weird. In number 4, we saw that the sin of minus anything just becomes the negative sin of whatever that thing was. So this negative is the same as this negative over here. So we know that the answer is going to end up with a negative in the front, and then what we're going to be left with on the inside is whatever came after that negative, which in our case is the 90 minus x. Okay, now on the previous slide we said that the sin of 90 minus x, remember these are the ones that just switch to the opposite, so we're just going to switch it to a cos, and we don't have to change the signs because the sin of 90 minus x simply becomes cos x, and the negative was already there. Okay, now I know that's a little confusing. I'm going to do the next example. So the next one says cos of x minus 90. So that doesn't look familiar. So what we do is we take out a negative as a common factor, and that's going to give you minus x plus 90. And so when you're plussing, the order doesn't matter. So I'm going to rewrite that as 90 minus x. Now, let me try to explain this a bit better. So picture this as the angle. Okay, that whole thing, 90 minus x, is the angle. And let's see what usually happens. So in number 3, we had cos minus x. And what that ended up happening was it just became positive cos of x. So there's the negative, just like we have a negative over there. So if we follow the same analogy, this should just give us cos of whatever the angle is. But our angle is 90 minus x this time. And then from the previous slides, we know that that simply switches to sin x. Please rewatch those last two a few times because I know that they are confusing at first. But if you just watch them a few times, it will make sense.